reinforce the concepts by going through certain questions as well. Okay, but before that, okay, remember that there are two segments that we were doing. I just want to address some of the questions that some of your classmates have. Okay, this first question here is from Iris. Actually, I don't understand the question. Why is there a point C? Where is the C in the first place?
The right angle.
The right angle triangle question. Okay. Let me come in. That one is practice now 3 question 2, is it? Come in. Yeah, good morning. Better than this one, is it? Is it this one? Because I really don't understand what your question is. What is your question?
A and B, I think then I can say why you must find the
Oh, you don't have to. Oh, okay. The explanation that I gave, is it? The video? I gave this A and B, and then after that I labeled this C, is it? Correct? Oh, this C is not necessary to find. It's just my explanation to you, okay, to why the formula works that way. Yeah, so if you don't see, then you don't know this length one. I'm just trying to break down the whole thing, okay? Now I understand what this question is about, right? Okay, later I'll wrap up, okay? So I'll just run through these questions. And then this question here, do I need to know how the formula works? I have a hard time understanding how it works, okay? You don't need to know how it works. However, it will benefit you if you forget, okay, the formula, especially for the next person who asks this question doesn't know, okay, when to put minus, when to put plus. Okay, and that's the problem because if you don't know that, okay, you don't understand the formula, then you will be very confused. Okay, so I'll make use of just one example. Okay, to reinforce the idea of length of line segment. Okay, so if you're given the length of line, if you're given 2 points, let's say A has coordinates of 2, 3, and B has coordinates of 9, 7. Okay, this would likely be the diagram that we have. Agree? Okay, the diagram is not drawn to scale. It's really okay if you don't have a diagram drawn to scale. Okay, if you want to just apply the formula, then you got to just remember the formula. And the formula would be, sorry, let me just grab my markers out first. The formula will be this. Okay, x2 minus x1 squared plus y2 minus y1 squared, and then you square root it. Okay? Now, of course, there are people who don't remember this formula, and that's because you don't understand the formula itself. Why is it x2 minus x1? Why is it y2 minus y1? It doesn't matter is it y1 or x1 first or x2 first. They're just arbitrary coordinates. They're just a representation. Okay? So, if I want to apply that formula into this, how it actually works is that, okay, we should recognize AB as a hypotenuse. If I can form a right angle triangle, okay, it helps us to find the length of AB. Okay, so this formula stems from, it comes from this Pythagoras theorem understanding, the application of Pythagoras theorem. Because if I know the length of this, I square, plus the length of this part, I square, I will be able to know what is AB squared. For which I square root it, I will find the length of AB. So what exactly is this length? This length over here, if I know the coordinates, okay, the x coordinate will actually be 9, and then after the y coordinate will be 3. Right? So we know this length to be the difference in the x coordinate, so that will be 9 minus 2. Okay, and that will give us 7. So it's because of the difference in determining the length, that's why it is x2 minus x1. Okay, so my entire video, okay, at the beginning is to explain to you how the formula works. If you don't want to bother yourself with understanding how the formula works, you can go and memorize it. But there's a limitation to our memory, right? Okay, because there's so many things you need to remember. Okay, so the whole idea of this formula is that it comes from Pythagoras theorem. Okay, and this portion is due to the difference to find the length, and this portion here is to the difference to find the length here. Okay, so that's why it's minus plus minus, not plus minus plus. Because if you plus it, you don't get the length here. Right? So therefore 9 minus 2 gets 7. Over here, the coordinates will be 7 minus 3. That will give you 4. Okay? But if you want to just apply the formula, which is the expectation by the way, okay, is that we just have to take 9 minus 2 squared plus 7 minus 3 squared and then square root. Okay, so just apply the formula and you'll be able to get this. And the answer will come out to be square root 65, which we need truncated 5SF and then 3SF. Okay. 8.0622. So you get 8.06 units 3SF. Alright, yes, Julian.
Why do you use the final answer like units?
Because the question did not give us the units. So they are all in the arbitrary units. The word is units. They never say the coordinates is not like in cm. It's not 9 cm, 3 cm, right? So in units of okay. Right? Questions? Okay. So memorize the formula, apply the formula. Okay, then after that you get this. Right? But of course, understanding the formula, okay, will be due to your Pythagoras theorem. Right? Questions? Okay. Now, okay. So just to give you another example also, if I were to have maybe giving you these coordinates. Okay, negative 10, 2 and h, negative 4, negative 7. Okay, of course you're not expected to draw the diagram. You're expected to instead just apply the formula. So the expectation when it comes to your working, you'll do negative 10 minus away negative 4. Then square it plus 2 minus away negative 7. And then square it. Okay, so directly apply the formula. Okay, difference in x coordinate, then difference in y coordinates. Then you will be able to get, in this case, square root 117. Okay, there you get this answer. Questions? Yeah. Right, so those were from your exercise 4A right away. I want to run through this question here. Okay, because I saw a number of you didn't get this answer. So I'm curious how you all did it. Okay. It's similar to the one that was given in your SLS. Okay, so the question says that if the distance between the points A, which has the coordinates P0, and B, which has the coordinates 0P, if the distance is actually 10 units, we want to find the possible values of P. Okay, sorry, hidden by this instead of working, in case anyone hasn't yet copied. Okay, so how do we form the equation to find the value of P? Okay, question told us that the length of A the difference in the x coordinates will be p minus 0 square plus the difference in the y coordinates, so 0 minus p square. So this is the length of AB if you apply the formula by using the coordinates, and that will be equals to 10. So you can form this equation here. Okay, then you simplify this expression found in the square root, that will be p square plus p square. Okay, that is 10. So in other words, 2p square is found in the square root, and 2p square is equals to 10 square, which is 100. Alright, then after that, we find that p square equals to 100 divided by 2, that is 50. So p is equals to square root of 50. See? Okay, plus minus now. Okay, so plus minus square root of 50, and then press it in your calculator. The truncated 5SF value will be about 7.0 something. 0710. Plus minus. Okay, so P will be plus minus 7.07 in value. This is the 3SF. Okay. Any questions? Yeah.
The answer to the root form.
Okay. Usually for EMATS, let's say for answer to 3SF, you can leave the answer to the square root 50, that's fine. Okay, since we also learned certs already. Okay, but in EMATS, I think the general rule of thumb is that if you cannot leave it in exact, then leave it in 3SF. Yeah. Okay. You will accept both now. Alright. Okay, unless the question asks for something. Okay, let's move on. Do I erase the whiteboard?
Yes.
Can I? Okay, I want us to look at practice now 2. This is a question that I did not go through in the video. Reason being that I found it challenging to go through via video. Okay, so let's look at the question. It says that given that the coordinates of the points C and D are 4, -1 and -27 respectively, we want to find the coordinates of E such that it lies on the y-axis and CE equals to DE. Okay? So we need to understand the question first, right? And there's a lot of information. Okay? We know the coordinates, and then they say that E lies on y-axis, and also the length of CE is equals to the length of DE. Okay? If you were to just take the question as it is without drawing a diagram, I think it is rather challenging. Okay, so it might be helpful sometimes to draw a diagram. Okay, you don't have to draw something to scale, it's just drawing something that will help you. Okay, so since we're talking about coordinate geometry, we need our x-axis, y-axis, and the origin. So C is found on 4, -1. That's the coordinates. So 4, -1, perhaps C is here. Okay, then D it has the coordinates of -2, 7. So -2, 7, perhaps somewhere here. Okay, then they say that E lies on the y-axis. So it is somewhere on the y-axis, you do not know where. It could be above the x-axis, below the x-axis, or even at the origin itself. Okay, usually we try not to take the origin in our diagram because that is very specific and can skew your calculations. Okay, so maybe just take somewhere. Okay, it will be E, and then the question says that C to E is of the same length. Okay, so this is how we can interpret the question. Right? And because E lies on the y-axis, first question to ask yourself is, what kind of coordinates do we have? Are we able to tell something about the coordinates? What can we say? What is 0? X is 0. Okay? So X is 0 because it is on the y-axis. On y-axis, your X coordinate is 0, Y coordinate is something. So maybe let's call it A. Okay? So to solve this question, we let coordinates of E be 0A. Okay, our goal is to find out the coordinates of E, and given that CE is equals to DE, what that means is that the length of CE, using our formula for length of line segment, I will get 4 minus 0 squared plus negative 1 minus A squared. This is the length of CE. Then the length of DE, by using the formula, I will be able to get negative 2 minus 0 squared plus 7 minus A squared. Right? Yep. Or else what? I didn't assume that it's on the x-axis, it is on the y-axis actually. Yeah, the question says that it's on the y-axis. Okay, so now that we have formed the equation based on the given information, we can solve for the A value here similar.
So when it says lie on the y-axis, that means it's 0.
X coordinate is 0. We agree, right? Our coordinate system, anything that is on the y-axis, your x coordinate is 0. Correct? Anything on the x-axis, your y coordinate is 0. Right? Okay, so 0, A, and then A, 0. Okay, so we solve. Okay, you can square both sides in fact. Okay, then get rid of the square root. You have to continuously write the square root sign. So 4 minus 0 square is 4 square. This one, okay, how to simplify it? Take note that there's negative itself. Okay, several ways that you can do it. If you want to apply your expansion formula, your identity itself, you just need to be careful. Okay, otherwise, how I will usually do it is I factorize out the negative 1 and think about it in this manner. Okay, because once the negative is being squared, there's no more negative to talk about. Okay, let me just finish this up first. Okay, so 4 squared is 16. So negative square is positive 1. We are just focusing on 1 plus A squared itself, which is much easier for us to expand. Okay, so 16 plus 1 plus A bracket square will be 1 plus 2A plus A squared. Okay, so we simplify the equation. 17 plus 2A plus A squared here, 53. Okay, take all the A's onto one side. And we have 16A equals to 36. Right? So A equals to 36 divided by 16, which leaves us with 2 and 1. Any questions? Okay, if you're okay, could you give part B a try on your own? Okay, it says that F is actually on the x-axis in this case. So how will we actually define the coordinates of F such that we can find the coordinates of F? Okay, similar set of working, just that the coordinates of F will be different. Give you about 5 minutes to walk in, okay? Can I go through the answer? Maybe before that, are we done with part B? Part B only, not yet find the area of triangle. Okay. I mean, you can find area of triangle, that's great. Okay, but I just wanted you all to focus on part B. Okay. Before that, I thought that I want to address why did I do this, Okay, why I factorize out -1 and then after you get this. The reason is because I noticed over the years, whenever I give you a negative number over here, okay, followed by minus something, and if you want to try to use your identity here, most students tend to make mistakes. Okay, what kind of mistakes do you make? Right? So this is the formula we're trying to use, correct? Okay, for this expansion, -1 minus a squared. Okay, what is the a in this formula and what is the b for this formula? Your a, by comparing, it should be -1. Okay, your b in this formula, by comparing, it should be the a in this expansion. You understand that? Okay, so when I expand this using my formula, how should it look like? A squared, then be -1 squared, minus 2ab, so 2ab plus b squared, which is a squared. Okay, most students tend to forget that the a is actually -1. So our result should actually be 1 plus 2a plus a squared. Okay, that's the problem that most people make. Okay, when they try to use the formula. Alright, then they actually forget that the a value is -1. This minus sign need not be accounted for. Why? Because in our formula over here, this expansion, this minus sign is already being accounted for in this minus over here, where we learn the expansion. Okay, so because of the trickiness in doing this, okay, which causes a lot of problems, that's why I decided that since we have learned our indices, okay, we can factorize out the -1, and we notice that in this case, I can have -1 squared, 1 plus a squared. And -1 squared is +1. That's why I'm only left with 1 plus a squared. Okay? So that's the reason why I do this. Rather than sticking with trying to apply the formula, which tends to make a lot of mistakes. You understand what I'm saying? Okay, especially in cases when both are negative values. So in such cases, I will usually factorize out the -1. Okay, to prevent any mistakes in expansion. Yes, Moses?
Maybe it's easier to use a squared plus 2ab because then you can start with
You can, but I think most people don't do that. People always see the center minus and think of this one. Yeah. That's the, I mean, if you do the plus one, that will be great. Yeah. Then it will be a different scenario lah. Yeah, your A will have to be -1, your B will have to be -a. Yeah. So you must have the awareness about what you're applying and know what is it that you're using. Yeah. If you are just blindly applying formula, okay, then the mistakes come out. Okay, so need to assess of awareness. Okay? Okay. So this one is done, Right? Now let's go back to part B. Answer part B. Okay, so this is any letter that you want. Then after that, more importantly, the y coordinate is to be 0. Okay, so then because the question says that CF is equals to DF, applying our length formula, it will tell us that CF will be 4 minus away B, and then negative 1 minus away 0 squared, equals to DF, which will be negative 2 minus B squared plus 7 minus 0 squared. Okay, so 4 minus B bracket square, we will get 16 minus 8B plus B squared. I can remove the square root sign already. Negative 1 minus 0 is negative 1, followed by a square is a positive 1. Okay. Over here, negative 2 minus B squared, just now I've already demonstrated that it is equivalent to the expansion of 2 plus B bracket square plus 7 minus 0 squared, that will be 7 squared, so 49. Okay, so we expand this, I will get 4 plus 4B plus B squared. Then I will have 17 minus 8B plus B squared equals to 53 plus 4B plus B squared. Placing all the B's to one side, I will be able to get negative 12B equals to 53 minus 17. That will give us 36. Okay, so our x-coordinate of F will be negative 3. So that's the coordinates of F. Okay. Questions? Right? Long is wake up. Okay. Next we look at the last part of this question. It says hence find the area of triangle OEF. So that is the thing that will be difficult if you don't have a diagram. Okay. So having a diagram will help you to visualize what is triangle OEF. O is the origin, E is actually on the y-axis, F is on the x-axis. Okay, so if I were to enlarge the diagram itself, F's coordinates are negative 3, 0, and E's coordinate is 0, 2 quarter, 2 and 1 quarter. Okay, so what kind of triangle is this? Triangle, right? And because it is a right angle triangle, it becomes much easier for us to determine the area because I can just apply my half times base times height formula. Okay, the base itself, if I were to take this as the base, how long is it? How many units? 3. Length should be positive, so this will be 3 units. And then the height will be how many units? 2 and 1 quarter. So the area of the triangle will be half times 3 times 2 and 1 quarter, which gives us a value of, we will get 3.301, 375. Okay, and the units will be unit squared. Okay, because it's area. Or you can put in fraction. So 3 and 1 over 8, right? See? Or 3 and 3 over 8. Questions? Okay. Move on to the last question for exercise 7, not for the day. Okay, looking at your exercise 4A, question 7. Okay. Could I get asked to find the lengths of AB, BC, and AC, part I, and then also try to find the area of triangle ABC. I trust that you are able to do that. Okay, before I come back to part 3. Okay, I'll give you about 6 minutes. Okay, I'll give you 8 minutes. Right, just go part 1 and part 2. Yeah. Ready? Right, few things to verify. First of all, this square root sign is a positive square root sign. It's not that always you square root of positive negative. Okay, so you must recognize that this symbol itself is a positive square root sign. So the fact that if you're still confused about this, I'm rather concerned about your A-Maths chapter 3. We are doing all the square root 20, square root 35, all your certs and all that. These roots itself is only the positive square root. It is not both, there are no two values to it. Okay, it's only one value. Okay, there's only one value attached to these numbers. Okay, only when you have to consider maybe x squared equals to 4, find out what is x, then because you're doing square root, you're applying the square root. Okay, there are two answers, that's why you get two solutions. Okay, but in this particular case, first of all, we're talking about length. Can length even be negative? That's why we don't even need to consider positive negative. It is only positive. Okay, so that's the reason. Okay, I want us to be sure about the square root symbol. Okay, next thing, must the length of line segment formula be applied to right angle triangle? No. Okay, it is just that length of line segment, so long as I have coordinates of 2 points, I can find the length by using the formula. That is the formula. Okay, that's the purpose of the formula. So in part I was saying that AB itself, there isn't a need for us to use the formula, because if you notice, it is a vertical line. Even if the diagram is not given, okay, if you observe that the x coordinate is the same, okay, if the x coordinate is the same, it is going to be a vertical line, because vertical lines have the same x coordinate, right? So therefore, when it is a vertical line, okay, you just have to take the difference in the y unit, y coordinates. Or in this case, since diagram is given, you just count the number of units. So this is 1 unit, 2 units, 3 units. So for AB, will just be 3 units without any formula needed to be applied. Okay? Then to find out the length of AC, we will have to use the formula since it is a diagonal length, or rather diagonal line. So negative 1 minus 3 square plus 1 minus away negative 1 square. So we'll get this. And the answer comes out to be square root 17, if I'm not wrong. Is it? Okay, sorry, AC is square root 20. So we get 4.47 units. Okay? And then for BC, similarly applying the formula itself, we will have negative 1 minus 3 square plus negative 2 minus negative 1 square. Okay? And then we will have square root 17. So the answer will be 4.12 units. Okay? So that will be your part I's answer. For part 2, to find the area of triangle ABC, we need to know where is the base and where is the height. At this juncture, we only have one formula for area of triangle, which is half times base times height. As we go on until the end of the year, we will have more formulas that will help us find the area of a triangle. Okay? So, area of triangle ABC, we use the vertical line, much easier. Okay, since down here is already 3 units, as per what you found in part I. If this were to be your base, where is the height?
C.
It will be from the base to C, right? Okay, which is a horizontal line for which we can also count the number of units. It is 4 units over here. Or it is just a difference in the x coordinate. So taking 3 minus away -1. Okay, so the area of triangle ABC will be half times 3 times 4. That will be 6 units squared. Okay? Yeah. Go ahead. Okay, part 3. Part 3 wants us to find the possible values of k given that E has a coordinates of 3k. So if you were to place the point E into the diagram, we know that it has an x coordinate of 3. That means that it is somewhere around here. It is along this vertical line here. Okay? We do not know its exact position. But we know that the area of triangle BCE, so B being here and C being here, and E may be somewhere here or somewhere here, the area is going to be 14 units square. So let's say, for example, if I were to take E to be here, okay, how does my diagram look like? Perhaps I clean up the diagram first. What confusion. Okay, so your point E is going to be somewhere along this line. I randomly chose that point to be E. So the area of this triangle here is going to be 14 units square. Okay? How do we find the area of this triangle? Half times base times height, right? What will be my base? BC, yeah? EC is here, right? Okay, if I choose this as my base. Then what will the height be? The height will be from the base all the way to your point B, where it is. So essentially it is this thing here. This will be the height, alright? So height here, base here. Okay? Okay? Now what if my point E is not above but below? Okay, if it were to be here. Right? How does my triangle look like? Okay, my triangle will look like this. My base will actually be different. Will be here. But will my height be different? No, right? My height will still be here. Okay, so it's just the base that is kind of changed. But my length of the height will actually remain the same. So what does this mean? Okay, this means that my area of the triangle, half times base, which is going to be CE, no matter what, my base is the length of CE, okay, times the height. Height will actually always be this length here, and this length is 4 units. It will be equals to the area of 14. Okay, so half times 4 is 2. And hence CE is equals to 14 divided by 2, so 7. We know that CE is going to be 7 units long. Okay, but my E can either be C or below C, right? It cannot be on C, because if it's on C, then it's not a triangle in the first place really. Okay, so 7 units above C, right? What will the coordinates of E actually be? E has an x coordinate of 3 as given in the question already. C has a coordinates of 3, -1. So 7 units above, okay, will be -1 plus 7. So it will be 6. So possible values of k equals to -1 plus 7 equals to 6, or else the other option is it is below C, so -1 minus away 7. Okay, so therefore the possible coordinates of your K will be 6 moles negative. Questions? Okay. So there's that two possibilities because question also emphasized that we're looking for possible values. Okay, so there should be more than one answer.